It's live. 21 classmates so that we can do statistics. I'm going to stop my video.
Hello?
Hi, Ray. How are you?
Hi, Karina. How are you? Walter, not right now.
I'm well.
Hey, I gotta take a couple minutes to get the kids down for nap time.
Okay,
So, but
I'm
I
here.
wanted to make sure that I could get in and everything.
Okay, I'm here. There should be one more person. So
Okay.
we'll wait.
Okay, yeah, I'll have this up and everything. I just wanted to make sure it worked because I had to install the plugin and stuff. This is my first time, so
Ah, good. Okay, sounds good. I'll put mine on mute, back on mute.
that's my daughter Phoebe, and they want to say hi.
Hi, babies.
Hi. She can't see you. Come here.
I can see her. How old is she?
She's 8.
Okay. I coach
Hi.
cheerleading to that age.
He's
Hi,
4.
baby. Hi.
Alright, are you done eating? Go finish your food.
Okay,
Alright.
I'll put mine back on mute and I'll finish. I was writing some stuff down, so I'll finish and I'll catch you back when you get back.
Let's see, how do I mute? Here we go.
Should
All
be
right.
able to see. Okay.
Thanks. I am back.
Okay. Hi. Let's see. I'm waiting on. Let me see. I'll send her a link just in case she can make it. When another student happens to be online right now, and I was going to meet her at 7, but if she can make it, then I won't have to rush home from the birthday party, right?
Okay, sounds good. Thanks for coordinating all of this, by the way.
Oh, it's no problem. It's kind of what I do, you know.
Yeah, I get that. I am pretty much the Grand Central Station around here, as you can tell.
Yeah. So you have just the 2 babies?
I do. I have 2 kids, 3 dogs, 2 cats.
Wow.
Yeah.
Wow. Yeah, I've got 3 kids and a husband, and I'm sure you have a husband too, so you know how that is.
Boyfriend, but yeah.
Yeah. Yeah. Same responsibilities, right?
Pretty much.
Yeah.
She does pretty well though, so.
Oh, okay, she said she can't join. So we'll go ahead and get started. I don't know where JP is, but maybe he'll join me at 7 as well.
Well, thanks for doing this one. I did not realize that you had 2 going on, so.
It's no problem. I thought it was going to be just the one, but I got invited to a birthday party at the last minute, so I wasn't doing anything at all today. And then they're like, "Hey, come to the party at 2," and I'm like, "Oh."
See, ironically, we had a birthday party to go to, but they lost the chance to go because they took like a week to try and clean up the upstairs. Because instead of cleaning, they were playing around. So my day freed up completely.
Wow. And how old are they?
8 and 4.
8 and 4. How awesome. How awesome. I have a 17-year-old in there, and I'm trying to get him to clean up, and it's like pulling teeth at that age. But I have 5-year-old twins, and they're much better about helping me clean up, so yeah.
Well, at least 2 of them are good. I've got 2 that they get distracted by playing, and I remember doing the exact same thing when I was their age, so.
Yep, exactly.
Figure it'll just be, the next however many years of pulling teeth.
Yeah, I wish I could say it gets better, but I can't.
It gets different.
Yeah, it does. That's the right word. So what I did was let me pull it up here. I found a few practice problems for us to kind of go through, and there we go. Because I know that you don't need, like all of anything else. It's just like this week that you were kind of.
Yeah, this week was, and I think I've been going through since last night, and I've been like basically copying down all the definitions of things.
Mm-hmm.
And then I'm going to be making a chart of all the different symbols that they use, because that was one of my biggest problems, is I was getting really confused with the different terms that they would use and the different symbols that they would use.
Yeah. Let's say.
And I think a lot of the problems you have to know the basics. Like you have to know the variance and you have to know the standard deviation. And from there you can pretty much get anything that you need.
Exactly. Right. This is what I did. That's what you're talking about. I wrote out.
Yes.
And then and I was writing it in my Word document, and then I was flipping from week to week looking for it, and I said there has to be a better way. So I wrote them all out, and then I left space because next week we're going to be talking about type 1 and type 2 error testing, which is alpha and beta, and so I'm writing all that stuff down, as we go, and it makes it so much easier.
Yeah.
Yes.
And that's what I was doing. Like I am just, because the book is really, really beneficial. Actually, I'm used to taking college classes where I really don't use the book at all.
Mm-hmm.
So this one I'm really using the book, but I also need to take the notes because I'm just flipping through pages at that point.
Yeah.
So I want to get a chart, and then I also want to get like an equations list. So to find this, these are the steps that you're going to do, because I'm a step-by-step person.
Yes. Well, right now this is not including the page of my little notations. I'm at 7 pages with equations. I did that too, and I specifically wrote out step number one. Identify, specifically what I have to look for in those steps, because otherwise it's just like it's crazy. And so what I found the problem with this week, as I was reading and everything, and I read, like I'll finish reading the chapter this weekend for next week, and so that I have all my reading done by the weekend, so that come Monday, all I'm really doing is looking at videos, and then I start my math lab work on Monday. I already have the reading down. But what I found my problem with the reading and the My Math Lab and all the videos was that I kept seeing things that said Z-test and T-test, and I was like, what is that? I felt like, okay, is there another equation or is there another step? What am I doing?
Yes, so, but it actually means the same thing, yes.
Yeah, it took me a whole day to find out it means the same freaking thing.
See, it took me all week to figure that out. So you're doing better than I am.
I was really upset, but I wrote it down in here just in case, I'm down the line at finals and I forget. It's just the same thing. It's just the S instead of the N. Oh, it took me, but, so, yeah.
I'm wondering if, because I don't think we're the only people who are taking notes, I wonder if maybe we can set up email each other our notes so that we all have, different notes. Does that make sense?
It does. And with one of our classmates, JB, I've been doing that since day one, because he's supposed to be here, but I guess he'll probably be here at 7, like I said. But he's been having trouble with the class as well, and so I've been just emailing him my notes along with them. Every time I take a note and I watch a video, I put the video in my notes as well, just in case I forget that step and have to go back to a video or whatever. So yeah, that makes total sense. We're at week 4, and from what I understand, it's going to go downhill. If you understand this week, everything else is kind of pretty much easier.
That's good. Yeah, I feel like right now I understand the concepts. Like, I understand the purpose of a null hypothesis. I understand, ideology is the best way to describe it, why they do a null hypothesis versus a research hypothesis, and why they go about it in the roundabout way. I get that, and I understand how to do the the calculations themselves. They're not difficult. They're tedious, right, but they're not difficult. So I understand that. My problem is I need to get a step-by-step guide in order to find the Z-score. This is what I need to do in order to find, everything else. So I need to rewrite my notes is basically where I'm at and try and figure all that stuff out. And that's what I'm probably going to do today, because I'm a procrastinator. I don't usually start my reading until Monday.
Yeah.
But I need to work on that tonight and just throughout the rest of the week, because I'm doing the problems and everything. So.
Well, I guess we can start with helping you rewrite the notes for finding the standard error for the sample mean, right? So let's get working on that problem that I found for us. And 3 of them on this page are different. So I said, well, we can work on 3. The first one we're going to work on is the number 1. Let's see. And you can read it. Sample size of n. Sample size n equals 100. X bar 16. Population standard deviation of 3. And we're going to be looking for a 95% confidence interval. And so from there, let's hear how you would work on that problem, and then we can see where.
So I would take the standard deviation, which is 3, and I would square that to find the variance, and that would be 9. And give me 1 second, I'm going to go. I've been using the calculator on my phone.
Mm-hmm. I use Excel, and that's also what I submitted, and she said it was fine. It works great. You just have to type in E equals sum, and then, but you'd have to watch a video on it. It's simple once you see it, but it's really, really easy. It does a lot.
Okay.
But go ahead.
I am very much a pen and paper kind of person.
Yeah, okay.
So I've been just writing it out, and I think for me that helps me get the steps down a little bit better too.
Okay.
So I would get the variance of the standard deviation, which is 9, and then I would divide that by 100. And that would be 0.09. And that equals the variance of the distribution means, right?
Right.
Okay, and then I would take the square root of 0.09, and and that is 0.3, and that is the standard distribution, or the standard deviation of the distribution of means.
Good. Standard error means. Good. So good. That's the first part of it, and then the second part is to actually find the 95% interval.
Yeah, and then for the confidence interval, you want to do, for the upper limit, you would take the sample, no, the population mean.
Double check.
No, you would take the sample mean and you would subtract the population mean.
Nope. For this one, we're going to be solving for what I call on my notes X. So we would take the sample mean, which is 16, and then we would add or subtract, in this case both, add and subtract two different equations, the 1.96.
Oh yeah, that's right. Okay, I'm thinking of a different one. And then you're going to multiply that by, you're going to multiply 1.96 by the 0.3.
Right.
Okay, that's right.
And then, right, that gives you your upper and your lower. And that, I think that is sounds like that's where, because that's the step I also got confused on. I was like, okay, do we multiply, divide? So it's the same old equation that we had before. M or X bar plus or minus the confidence interval, which in this case is 95%, and then times the standard error of the means.
Yes, I was getting confused with the z-score for the distribution of means. That's what I was getting confused with. Because in that one you have to know the mean of the population, the general population, in order to find.
Good. You got it. Good. Right. So the final answer of that sounds like you would know it. The upper limit is 16.59, and the lower limit would be 15.41 for that. So then
16.59. I'm doing the calculations right now. Sorry.
That's okay.
I'm working on my calculator, so I want to make sure that I get it right. Oh crap.
So yeah, like you, I write everything down. I write it down, and it's a 5-step process, pretty much is what it is, to find the standard deviation, to find the standard error of the means. And so what I do is, for number 1, I'll write, and I actually let's see if I can show you how I actually do the same thing, I guess, that you do. So, like, I'll number it. Yeah.
Yeah, that's pretty much.
Yeah. And then from there I go, and I keep the numbers in Excel, because if it is a 0.235, it might round up the next number, which I found can actually mess up the last number if you don't keep all the points.
That's why she wants us to do it out to 4, I think.
Yeah. So yeah.
Fine.
So just to reiterate, let's try question number 10. Give me a second. Okay. Question number 10. Installation of a certain hardware takes a random amount of time with a standard deviation of 5 minutes. A computer technician installs this hardware on 64 different computers with the average installation time of 42 minutes. Compute a 95% confidence interval for the mean installation time. So this is just what we just did, except now it's in a problem form, actual problem form. So we would do the same exact 5 steps again.
Yep,
and then
I already wrote it out. So I got n equals 64 mean, the x with the line over it equals 42, and the standard deviation equals 5?
Exactly. Right. So the first part of the problem would be to find the actual standard error of the mean, and that's that 5 part. The first standard error, standard deviation is 5, and then
You'd multiply that by 5, so
right.
you'd square it and then divide it by 64.
Mm-hmm. And then the part, what I call part 3, is the variance. And then from the variance, in order to get the actual standard error of the means, we take the square root of, and then we get 0.64. And then the second part of the problem is to actually find the confidence interval.
I got 0.63.
Okay. And then I rounded it up, I think. Let's see.
Because I got 0.625, and then I rounded up to 0.63.
Let's see. Okay, what did we do? You got point. Okay, so we took 5, and then we multiplied it by itself. Gave us 25. 25 divided by... What'd you divide it by?
I divided by 64.
Okay, and then you got...
0.390625.
Say it again.
0.390625.
Let's see. I put 26 by accident. 25 divided by 64. Yeah, 63. I got 0.6.
Okay.
25, 63. And then from that, and I've made that mistake before, and I actually made that exact mistake on the quiz. I was off by it was less than 0.2, and I was like, oh my,
man.
And it was the final question where, if you got the mean wrong, and then you went on to do your standard deviation, the whole problem was wrong.
Yep.
But she gave me half credit because I did, the calculations correct. But she was like, I don't know how I touched the wrong button when I was inputting. Oh my gosh.
Oh man, I didn't put the percentages for the frequency table because in all of the math lab problems we didn't put percentages, so I didn't even think to go back to the book and.
Right. I don't know what the average of the quiz is. Of course, I want to know. But right now, my class average, depending if she gives us a curve, if she gives us a curve, then it'll be an A. But if not, then it's just a high B right now.
Well, I'm getting full participation so far.
Yeah, right.
And that's, I think, is what's going to save me. I think I've got like I don't remember what, I think I got like a B on the quiz.
Yeah, right.
So I'll just have to see.
And then the My Math Lab is actually worth like a quiz percentage. It's actually worth like 30 or 40%. So.
Really? Okay. Well, I've been doing that, but I don't know what happened. But in week 3, I didn't finish half the problems, and I could have sworn that I did at the time. So I don't know what happened there, but.
Yeah, it's like 30 or 40. I was looking at it last night. Because, you get a chance to go back and correct your stuff, so you can pretty much get 100 in My Math Lab, Yep. But I didn't realize that in the very first week as well. So I was like, I know how to get the mean. I'm not going back. And I didn't realize it, so right now I'm at like a 97 in My Math Lab. And I was like, but it's all right. So.
Yeah, it's still a high grade, so.
Yeah, it is, I guess. But back to question 10. So we've got 0.63 as the standard error of the mean, and then from there we go on and we solve for, I don't know what you call it, I call it solving for the confidence interval. I don't know if there's actually a term.
Upper limit and lower limit is what
Upper limit and lower limit, okay. So then we solve for the upper limit and lower limit.
So for the upper limit I got 43.23.
And then for the lower limit, did you finish that one up?
Hold on one second.
Go ahead.
I got 40. 0.77.
Good, good. And then for this particular quiz, for some reason, it just tells you to go up to the one point after the.
So where are you getting this quiz?
Let's see. It's the University of Dallas, I think it is.
Okay.
But I'm a Googler, so yeah, I do a lot
I've
of
done that a
Googling.
couple times with definitions. Like if I can't find it in my notebook and whatnot, I'm just like, I'm Googling.
Yeah, I Google all the time. I should get a job at Google, you know. But I don't know. Would they hire social scientists, right?
Yep.
Let's see. And then, so for this last question, this is actually a little bit different, which is why I chose to do this question. So let's look at it. Bags of a certain brand of tortilla chips claim to have a net weight of 14 ounces. The net weights actually vary slightly from bag to bag and are normally distributed with a mean U.
Yeah.
Yeah. I can't remember what it's called. Oh, mu. Mu, I think it's called, right? That letter is mu.
I have no idea. I call it like I don't
Back
even
with you. I think it's called a mu. A representative. Oh, I can't believe it. A representative of a consumer ad. It's like really small, and I not.
It's
With my
okay.
glasses on. Advocacy group wishes to see if there is any evidence that the mean net weight is less than advertised. For this, the representative randomly selects 16 bags of this brand and determines the net weight of each. He finds the sample mean to be X bar is 13.82 with a sample standard deviation of 0.24. All right, and then from that data, we will find a 5% significance level. And so what I've learned from this week is the two different tests, I guess you would say, the significance level and the confidence interval. So for the significance level, it is another formula. We still have to find, no matter what, we're going to have to find the standard error of the mean. So, yeah, so let's get that out of the way. So for the
we want to find the z-score first, don't we?
You don't
want
need
to find the z-score of the sample because we don't know that. That's why they gave us. I think that's why they gave us the 14 ounces, which is the mean of the.
And in order to find the z-score for sample error of the means, you're going to need the sample error of the means. So the first thing that you will need to do is do that 5 steps, is to do the sample error of the means. And then it's solve for z, x bar minus m over the standard error. Yeah. So no matter what, we're going to have to find the standard error. So for these types of questions, if I see significance level or the confidence interval, I begin automatically finding the standard error. And so for this problem, we know that 0.24, and then I'll let you go ahead from there.
So 0.24 squared is 0.06. And then you're going to divide that by 16. And that's 0.0036. And then you're going to get the square root of that. 0.0036. And that's 0.06.
Right. Okay, good. And then, so when you see significance level, then you know we have to solve for z. And then that's when we do x bar minus m over what we just found, the standard error of the mean. So go ahead, you can compute that out.
Okay, so this one is the 13.82 minus 14 divided by 0.06. 3.8. -3.
Okay, good. And so we know that our confidence interval or our significance level is at 5%. So a 5% significance level is also a 95% confidence interval, which is 1.96.
Yep.
So it's 3 bigger or smaller than 1.96.
Smaller.
So therefore, the null hypothesis is.
So we can't reject the null hypothesis.
The null hypothesis is actually rejected because there's actually less chips than what the manufacturer is saying that there should be.
Okay, yeah, I see what you're saying. Never mind.
Yeah. So,
I got it in my head, but I said it wrong.
When to actually to reject the null hypothesis, I actually have to write out the actual step 1, HO and H1. I actually have to write that. I can't do it in my head like that. I really just can't. But you've got it. And so that's the 2 things to take away from this week, I think, is the significance level or the confidence interval. If it's the confidence interval, then we're pretty much solving for.
Then the only different step in the confidence interval is that the last one where you're doing the upper limit and the lower limit, which is
exactly
the sample mean plus the 1 or plus or minus 1.96, and then the times the standard error.
Right.
And then
now you also I just want to make sure that it doesn't always have to be 1.96. It always depends on. Right.
It doesn't.
Okay. Good.
That's just for 0.95, which is the most common one that they've been.
Yeah. Right.
But no, I think other ones they've used like the 99.
Yeah.
And then for the statistical significance level, you're going to be finding the z-score at the end, which is the sample mean minus the general population mean divided by the standard error.
That's it. That is it, exactly.
I finally figured out all of the symbols that they use. And I think what helped me out was I went through and I did in the math lab how they say, help me solve this. I will go through and I'll do that, and they break it out step by step, and they give you the symbols and everything like that, and that is honestly what finally helped me out. And this was like last minute Saturday morning. I'm sitting there with tears pouring down my face because I don't get it, and I'm like, I don't know what's happening.
I know the feeling all too well. If I could be a sponsor for my math lab, they are awesome. But there's another link that she posted in their stat track. It's under course resources.
Okay.
And that's where I found the entire list. There's a list of more symbols than I know what to do with, so I pick out the ones that I need.
Yeah, I sent her an email and asked her if she had a list, like a cheat sheet, and she's like, no, I'm not going to give you a cheat sheet because I think you'll learn it better if you write your own. And writing it helps kind of like seals it in, so yeah. Well, you've got it. That's the difference that I've taken away. From this week, and from here on out, it seems like it's pretty much easy. Next week, everything from here, it seems like so far peeking at the syllabus and everything, it seems like everything is just pretty much making sure that you've rejected the null hypothesis correctly. So it's checking, the sample size and things like that. So I think as long as you understand that concept, then you should be okay.
Yeah. Cool. Yeah.
Well, did you have anything that you needed to work on, or?
The only problem that I keep having is the stupid table, and this thing. I hate this thing.
Really, I love this thing.
Oh, I hate it. And so every week during the conferences with the peer leader, I'm like, the table again? He's like, yes, Karina, the table again. And I'm like, he's like, unless you want to do calculus, this table is your best friend. So right now, I told my husband last night, bring on calculus.
I love this table. I love this table.
Okay, so what the problem that I'm having is, I guess I don't know where to look. I can do my formulas and get the number, and then I get the number, and then I'm like, what part of the table do I look it up in? So he's like, it's like algebra.
Yeah, kind of. So what? Okay, so let's do like one of the statistical significance.
Okay.
So if we're looking for, let's just do.
It's -3%.
So if we're looking for a, like the reason why it says in a 95% confidence level, we're looking at the 1.96, the z-score, the 1.96.
Right.
So if you look over to the part that says the percentile, what does that say?
2.50.
So if we're doing a two-sided test, then we want to have 2.5% in one side of the tail and 2.5% in the other side of the tail.
Right.
So that's why it's 1.96. But if we're doing a one-sided tail, and what would the z-score be for that? What would we be looking for the percent in the tail?
So 5%, and the closest is the 4.9, which is the 1.65 z-score. So what is the middle? What is the middle for?
That's from the mean to the z. So that's the percentage. We haven't really covered it a whole lot in class, but that's the percentage of from the mean to the z-score. So let's see. If you're seeing how many people are between the average and the score that you got in class per se, then you would be looking at that sign. Like you would take your z-score and you would compare that against the chart. So say you got a z-score of, we'll just do 1.64. 44.95% of people are between you and the mean.
So that's very well.
So that's 45.95% of the scores are between.
So then anything in the middle pretty much has to be subtracted from 100 in the middle column, or
well, no, you would be adding 50 to it.
Adding 50 to it.
Yeah. So I think it goes over it in chapter 3, I want to say. Hold on, let me find it. I just looked at it last night. Give me 1 second and let me find it. So do you remember when they first talked about like doing the curve and drawing it out, and getting those steps? That's where it talks about it.
So that's like chapter 2 or chapter 3. Chapter 3, yeah.
It starts on page 74 of the text, 74 and 75, and where it does those steps, here it is, page 79, the steps for figuring the percentage of scores above or below a particular raw score or z-score using the normal curve table. So that's where you get the formula. So first you change, like if you have a raw score, like if say you got a 75 on a test, okay? So you, hold on 1 second. Walter, go back upstairs, please. Go climb into bed and take a nap, please. No, you need to take a nap right now. It's quiet time. Do you want to spend the rest of the day in bed? Then you need to go night-night like I told you to. I'm sorry, I will try and talk quieter. Close your ears. Sorry. So say you got like a 75 on a test, then you would have to change the 75 to a z-score. But you'd have to know the mean and the standard deviation. So let's see, say I don't have a problem for it, so I'm going to have to try and make it up.
Okay.
I don't even know what's a good one. So say the mean was, like 82, and the standard deviation is 2.
Okay.
So to figure out your z-score, you would be doing
75 minus 82 divided by 2.
Yep, divided by 2.
Mm-hmm.
And that would be, I don't even know if these numbers are going to work, so if they don't, I'm sorry.
That's okay. .3.
So your z-score is negative 3.5.
Right, okay.
Okay.
And then so I would
go ahead.
Go to the chart, and for my z-score, go to the actual z line that says 3.5. Which it's 0.02% in the tail, so I did better than 0.2, or is there something else that I need to do?
Nope, so you're going to take the rough estimate. So this is where you're going to be doing, this is where you're looking at the middle part of it. So you see where it says 49.98?
Mm-hmm.
So that is how many people between your score and your z-score.
49.98 between me and the middle.
So this is where drawing the actual bell curve kind of helps you out. So you draw it like this. Let's see if you can see it. Can you see that?
Okay.
So the mean right here is 82.
Mm-hmm.
And then no, where is it? Okay. Forgive my drawing, I am not an artist at all. Do you remember that chart?
Yes. Mm-hmm.
Okay. Mm-hmm. So this is where you kind of shade it, like you find roughly where your score is. Mm-hmm. So you know that one standard deviation around this is, one standard deviation down is 80, and then 2 standard deviations down is 78. Mm-hmm. So that you know that your score is 75, so it's somewhere in this bottom 2%. Mm-hmm. Like this.
Right. Okay.
Okay.
So then if I'm asking how many...
So that you know that you're somewhere in the bottom 2.5%, and if you look at the chart, at 3.5, then the percent is in the tail is 0.02, but the percent from your score to your the mean is 49.98, and that covers basically from there to the mean. I don't know if you can understand my drawings.
Right.
So that covers that part. Now, in order to find out the rest of the class that scored above the mean, then you would add 50%.
I get it.
You do?
I get it.
Okay. So that's what the middle column is for.
To find people above. Or can I use it to find people below? I guess I would use the tail to find.
Exactly opposite, yeah. Okay. Like if you had gotten like a 90 on your test, then you would have figured out the z-score for that, and it would have been the top. And then you would have still added from that bottom score, or from your score to the mean, which would have been on, it would have been on this side of the chart. You would have been up there. So you would still have found from your score to the mean, right here, and then added the 50%.
I get it. I love light bulb moments. I wanted to throw this thing away. I really did, but now, okay, I get that. Okay, now let me make sure I understand the tail. When do I go to the chart and look at the tail? Because I know how to figure out a z-score, so aren't I always going to the chart just looking at the z-score? And
Not necessarily. So say you're doing a confidence interval and it's not 95%, which you've already memorized is 1.96. Suppose you want to find an 80%. You would go to the chart and you'd be looking at how much is in the how much would be in the tail at that point. You would have, let's see, that's 20% that you want to find, so it would be 10% on each side.
Okay, wait a minute. Let's say that again. Okay. So if I'm looking for a confidence interval, what did we say? Like 90% confidence. Well, we know that. I
like
know that one off the top of my head, too. Let's say 88% confidence interval.
We can do 90. 90 works, too. Oh,
okay.
Do you know that one off the top of your head?
I'm pretty sure I do. I'm pretty sure it's... I know it's written down. 1.5%. No, okay, we can do 90 because it's not on the top of my head.
Okay, so how much would be in the top and the bottom? Like how much would be in the tail at the top and the bottom?
It'd be 5% in each
5%. So you would go and you would look in the you would look on the chart for the percent in the tail, so you would be finding 5%.
So am I looking for 0.5 or actual 5? Or
you would be looking for actual 5 because the 0.5,
because it says 5%.
The 0.5 is the 99%. Remember?
Right.
The 2.57.
That's the problem that I had too, because I wasn't sure if I have to, move the decimal in order to convert a percentage.
Nope. It's in percentages. So you'd be looking for the closest to 5%.
Which is 164. I knew that number. It's
so
164.
Do the same thing with 80%. How much is going to be in the tail?
And we're going to have 10% in each tail.
So what would
the be? The closest, I guess, the closest z-score would be 129.
1 point what?
1.29.
I would probably go with 1.28 just because
okay, it's a little closer.
0.03 is closer to 10 than 0.85.
Okay, I see that.
Does that make sense?
It does. It does. It does.
Because while the most common z-score, like the most common one they were talking about in the test were like the 95, so the 0.05, and the 0.01, which is 99. Just because they're the most common doesn't mean they're the ones that are always going to be used.
Right. So 98%, we would say there's 1% on each side, so we would look at 1% in the tail, and that would be 2.33.
Yep, exactly.
Okay.
And that's all you're doing is looking for the Z, the cutoff score at that point.
Right. Okay. I don't know. I'm still questioning this thing. And maybe because I was looking at it and there's so many numbers in between missing. I don't know.
What do you mean?
Like 0.40. Like if we go to the z-score of 0.01, and then the percent in the tail is 0.40, and then 0.02 z-score, the percent in is 0.80. So there's numbers missing somewhere in there.
So I think the problem with that is probably, like, in order to figure out why that is, that's probably where you're going to have to pick up the calculus.
Calculus, yeah.
And as high as I go is algebra, so.
Well, I'm pretty sure in grad school, I know in grad school I have to take one more, some type of math, and I was really leaning towards statistics, but I'm like, I might need to know calculus, because you can't feed me this and say, okay, just rely on this. But there's stuff missing. I don't like stuff missing.
Hit the I believe button.
Yes, I guess. That's how it's, yeah. So, well, I guess that's it. I understand the chart to a point. If I need you, I will buzz you, though.
Okay.
If I need you. And then you got this week's stuff, so that's it.
I can't teach you why there's stuff missing, and I cannot teach you the calculus behind it, but I can at least guide you to, hey, this is what you need to look at.
Because every time I question that, the peer leader, he's like, look, that's calculus, and I'm not teaching calculus. Okay, fine. And then go with the chart then. But I'll be doing calculus one. And then the problem that I'm having with statistics in general is that it's really fast paced in our class anyway. And I only have time to grasp the concept, and I'm not able to question I'm not able to question it because I don't completely agree with statistics, and that might be the social scientist in me, or it might be the philosopher in me. I don't know, but I don't think I completely agree with everything that we're learning here, and that's weird. But
So, they actually have like sections in the text about the controversy there.
yeah,
Have you read them?
I've been reading them, and I've actually seen a few videos, but I don't like math.
I don't like math
Know?
either.
And so that's where it really gets tricky. And so my husband tells me, make your own math. You know?
So I have no intention of being a research psychologist. So
okay.
I am really only taking this class because I have to be able to read statistics in order to understand them. So I think that it's beneficial for me there. But I want to go into more practicing psychology. So when I get my graduate level degree, then I'm gonna lean more towards the PsyD rather than the PhD. So I am hoping that I don't have to understand more than just a general bit of statistics.
Well, I know in grad school, are you going for your PhD or your MA?
So I will have to eventually get the doctorate. So I want to try and do a PsyD program.
Okay.
I don't know if I'm going to go straight from bachelor's to a doctorate. I have to figure that out because I'm still in the military. So the goal.
Oh, I didn't know that. Okay.
Yeah. So my goal is to retire in the next like 8 years and finish up my bachelor's while I'm in, and then either start on my master's while I'm still in, or start on the doctorate when I get out, because there's only so much that tuition assistance is going to cover. So I just need to figure it out, and I'm not really sure if I can go from a bachelor's to a doctorate.
Yeah, that's unfortunately for the programs that I'm looking at, they don't offer master's degrees. Because I do want to be a research scientist, So, but right now I'm looking at USF right here around the corner. They got a lot of great stuff going on, so I'm excited about that. But they have no master's; it's straight to your PhD. And then there's another program. Actually, my first choice is UWG, University of West Georgia, which is about 6 hours from me. But we would just all move up there. But they have a master's degree program, but you don't get stipend. Like, you don't get paid in the master's degree program, whereas in the PhD program you do. So I'm not looking to work. You know, I need to focus. Yeah.
That's why I want to retire before I start a doctorate level. I think, because I know that I know that as a stepping stone, I can get a master's degree, and then when I get out, I can either find an internship with a master's degree and work on my doctorate at the same time, or I can, just use the master's degree as a stepping stone into the doctorate. So I just don't know which one I want to do, but I know what I have to do right now.
Yeah. And that's practice class. Yay! We will do with flying colors. But
yeah,
it was awesome. Thank you for going back over the Z table, and we're through this week. Next week it seems kind of really easy. Like, seriously, really easy. I'm almost done with the chapter, and I'm like, everything really seems downhill from now. And it's another one of those logical things where, well, if you reject the null hypothesis with a 95% confidence, then there's 5% that it's wrong. You know, that is literally your type 1 error. I mean, it's like...
Didn't we already cover that, though, in Chapter 4?
It's like a no-brainer. And then your type 2 error is if you accept the null and the research actually is true. Where if you for what you'll be doing into psychology, if you're testing a drug and you say, oh, the drug doesn't work, it has no effect, but it actually does work. So that's the type 2 error. But no matter what you do, there's going to be an error, because we can go to a 99% confidence interval, and then there's some other stuff about the sample size, which we're getting into as well this week. But statistics pretty much is telling me that anything within a certain limit is possible.
Which kind of makes sense.
It does, but that doesn't answer anything for me. It doesn't answer anything for me. It says, oh, well, maybe, kind of, sort of, 1%.
Well, that's pretty much what it is, though. Like, like with psychology especially. Like, I think that other statistics are a little bit more hard and fast, but like with psychology, there is so much variation between just people in general. How are you supposed to tell what one factor, what that effect is going to be? So that's why, again, like why it's so fuzzy.
And that's the direction that I guess my research is going into. The me, what are you? Consciousness is what I'm experiencing. Is what I'll be studying. So the me, is there any way I can actually tell that you're really conscious? And we're not going to get into that because that gets really deep right now.
Fascinating, though. It sounds fascinating.
It is, and then that brings me back to statistics. Is there any way that we can, without a doubt, 100% prove that there are no mermaids? Statistically, we cannot.
Well, I mean, statistically, there's a lot of things that we can't prove. We can't prove, like, for instance, we can't prove that there is one God or many gods or no God. Like, statistically, that's impossible. We can do a study based on how many people believe in those things. But even that is not going to be a 100%. So.
Exactly. And so hopefully my future research will somehow, and that's a part of my research too, not so much God, but, well, of course, to study consciousness, you have to look at things outside of what science believes right now. So. Right, but my claim to fame, hopefully, I started in my undergraduate degree, is I'm trying to create an interdisciplinary study towards consciousness. Because everybody is doing their own thing, studying it. We're never going to get anywhere unless we all get together.
Yeah.
So hopefully that's my claim to fame, is that I'm starting interdisciplinary, what do I call it? The interdisciplinary approach to studying consciousness.
That's pretty awesome. Good luck with that.
Thank you. Okay, let me get the kids ready for the birthday party. It was great, Ray, and we will see you in the forum, yeah?
All right, I'll see you later. Thank you.
Okay, bye.